Welcome to question 4 of chapter 6, the residual chapter of the regression models book. This question says, load the MT cars dataset. Fit a linear regression with miles per gallon as the outcome and horsepower as the predictor. Plot horsepower versus the residuals. And of course, interpret your plot. So here I have my code. I'm going to fit my linear model, miles per gallon as my outcome, horsepower is my predictor, my data is MT cars. I'm going to create, in question 1, which was a similar question in this chapter, I used base R graphics. Now I'm going to use ggplot. I'm going to create a data frame, which I'm going to uninspiringly label temp, that is exactly the MT cars data set, but I'm going to add the residual vector to it. And probably, if I was being better, I would name this a better name than temp, and also I would use dplyr as a good package for doing this in a little bit more elegant of a way. Okay, so I'm going to create my ggplot. My aesthetic is set so that my x is horsepower and my y is residual. I'm going to add a horizontal line in red as a reference line, and then I'm going to add the points, and then I'm going to do the plot. There we see our plot. The residuals are on the y-axis, horsepower is on the x-axis. If I look at this residual plot kind of carefully, I do see some potential of nonlinearity. So the residuals are mostly positive, then mostly negative, and then mostly positive again. So this is an instance where there's at least the inkling of a pattern in the residuals. There's also this cluster of points right here. I might also want to just replot the original data in this case because there's only 2 variables. So I'm going to do qplot horsepower miles per gallon data equals MT cars. I want to look at the original data set, and we see that first of all, here's those 3 points, those where they're coming from, and we do see some potential for nonlinearity in this data set. So maybe when we fit our model, it might be useful to add a squared term to our regression model fit.